Okay, so in the last 3 lessons, we're going to learn 3 new identities. The cosine of the sum and difference of 2 angles, the sine of the sum and difference of 2 angles, so 4 more identities, sorry. Your double angle for your cosine function and your double angle for your sine function. So for the next 2 days, we'll work on the sum and difference for cosine. Now, like I had mentioned before your last quiz, you will be given these identities on a reference sheet. If you're adding 2 angle measures together, you can't simply distribute the cosine function, right? It's a function, it's not a number. So take the cosine of the first angle measure, the cosine of the second angle measure, change the operation from the original, sine of the first angle, sine of the second angle, and then we multiply these individual values. For the difference of 2 angle measures, same deal. You're not allowed to distribute the cosine function. So the expansion, cosine of the first angle times the cosine of the second angle, change the operation from the original, plus sine of the first angle times sine of the second. Alright, so first we show you how the expansion works. When you simplify to an exact value, okay, cosine of pi over 2 from our exact value chart we know is 0, cosine of pi over 3 is a half, plus sine of pi over 2 is 1, sine of pi over 3 is square root of 3 over 2. Simplify each product. 0 times anything is 0, 1 times anything is itself. So this is what your final answer is. Square root of 3 over 2. Now check out what the expansion was. Cosine, cosine, add sine times sine. Well, this is the expansion for cosine. My 2 angle measures are pi over 2 and pi over 3. But when we're dealing with cosine, the operation in the expansion is opposite the operation of whatever we're doing with the angle measures. So we would be subtracting these. Alright, so we just check square root of 3 over 2. If I wrote it as a difference, that's what it would look like. Cosine of pi over 2 minus pi over 3. Do we know where cosine equals square root of 3 over 2? From our exact value chart, cosine is equal to square root of 3 over 2 up at pi over 6. So we have that as well. And then check it according to the formula. Pi over 2 minus pi over 3, getting a common denominator of 6. It verifies that theta is equal to pi over 6. Alright, so simplify as an exact value. Cosine of pi over 4 square root of 2 over 2 times square root of 2 over 2 minus square root of 2 over 2 times square root of 2 over 2. Top times top gives me 2. Bottom times bottom gives me 4 in both fractions. Anything minus itself would be 0. So what angle is this referring to? First angle, second angle. Change the operation. When the denominators are the same, I just add the numerators. So what angle is this referring to? The cosine of pi over 2. Cosine of pi over 2 from the unit circle, we know the x-coordinate up there is 0. So it verifies an exact value of an angle we already know. Cosine of pi over 3 is 1/2. Cosine of 3 pi over 4. 3 pi over 4 is in the second quadrant, so its exact value is negative. Sine of pi over 3 is square root of 3 over 2. Sine of 3 pi over 4, it's in the second quadrant where the sine is still positive. Top times top, bottom times bottom, top times top, and bottom times bottom. Now, we would see this answer one of 2 ways. Negative square root of 2 plus square root of 6 over 4. Or, changing the order of the numerator, you can write it as square root of 6 minus square root of 2 over 4. You just have to make sure you write your answer as one fraction. What angle is this referring to? Well, the two angles given in the expansion are pi over 3 and 3 pi over 4. Because we're adding on the expansion, we'll subtract the two angles. Common denominator is 12. 4 times 3 gives us 12. Multiplying this fraction by 4 over 4, this fraction by 3 over 3. So we get 4 pi minus 9 pi over 12. That gives us negative 5 pi over 12. So this found for us the cosine of negative 5 pi over 12. Now notice that this fraction cannot be determined from the exact value chart, nor can we find any values from the unit circle. So what these new expansions enable us to do is to find the exact value of unknown angle measures. Alright, cosine of 7 pi over 6, it's in the third quadrant, so the cosine has a negative value. Reference angle of pi over 6, so negative square root of 3 over 2 times 1/2 cosine of pi over 3, minus sine in the third quadrant is negative as well, negative 1/2 times positive square root of 3 over 2. Top times top, bottom times bottom. Over here, when we multiply the two negatives, it becomes a plus square root of 3 over 4. These are opposites of each other, so our answer would simplify to 0. What angle are we referring to? 7 pi over 6 and pi over 3 are the two different angle measures. Minus in the expansion means I'm adding these together. Common denominator is 6. So the 7 pi doesn't need to be multiplied by anything. But my second fraction, I'm going to multiply by 2 on the top and bottom. So I get 9 pi over 6. Simplifying this, I get 3 pi over 2. 3 pi over 2 is a known angle. It's down here on the unit circle where the x-coordinate is 0. So it verifies the answer we got from the expansion. Okay, so cosine of alpha plus beta, cosine of the first times sine of the second. Change the operation. Oh, that's wrong. Sorry. Cosine of the first times cosine of the second. Change the operation. Sine of the first, sine of the second. When we're subtracting two angle measures, cosine of the first angle times cosine of the second. Change the operation. Sine of the first angle measure times sine of the second angle measure. So all you need to know is the original being added or subtracted, and that determines the expansion we use. We're adding, so for this, cosine of the first angle measure times cosine of the second. Switch the operation. Sine of the first angle measure times sine of the second. The big plus sign, that's adding the two terms together. Cosine of the first times cosine of the second. Change the operation. Sine of the first times sine of the second. Now let's simplify using what we know about pi over 2. Pi over 2 is up here on the unit circle. Coordinates are 0, 1. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. 0 and 1. And then multiplying. Anything times 0 is 0. So I have 0 minus sine x plus 0 plus sine of x. So this entire expression evaluates simply to 0. Alright, using the same line of reasoning, cosine of the first angle measure, cosine of the second, switch the operation, sine of the first angle measure times the sine of the second. I'm subtracting both originals, so minus cosine of the first times the cosine of the second angle. Change the operation in the parentheses. sine of the first times sine of the second. 3 pi over 4 is in the second quadrant with a reference angle of pi over 4. So this evaluates to negative square root of 2 over 2, positive square root of 2 over 2, negative square root of 2 over 2, positive square root of 2 over 2. Multiplying, I would get negative square root of 2 cosine of x divided by 2 minus square root of 2 sine of x over 2. Distribute the negative. The opposite of this negative square root of 2 over 2 would make it positive. And then the opposite of this positive would make it negative. Negative square root of 2 over 2 cosine will cancel with the positive. Now look at what I have. Negative square root of 2 over 2 sine x minus square root of 2 over 2 sine x. Like terms, common denominators already, so we just subtract the numerators. It's the exact same numerator. So I have 2 of the exact same thing. These 2's cancel, and I'd be left with negative square root of 2 sine x. So that expansion had a little bit more to it than the previous one. Alright, now we can use our expansions with proofs. On the left-hand side, cosine of the first, cosine of the second. Change the operation, sine of the first, sine of the second. Cosine of pi over 2 is 0, sine of pi over 2 is 1. So I get 0 plus sine x. Exact same function on the left as it is on the right. Okay, on the left-hand side, cosine of the first, cosine of the second. Change the operation, sine of the first, sine of the second. From the unit circle, cosine of pi is negative 1, sine of pi is 0. So I have negative cosine of x plus 0. And I'm left with the exact same function on the left as is on the right. Okay, and this ends day 1.